Hey, this is Rob Hoskin of Building Performance Architecture, and welcome to this episode of BPA's QA/QC drama. QA/QC is short for Quality Assurance and Quality Control, and that's what we do at Building Performance Architecture. Most of our QA/QC work revolves around energy efficiency, making sure that buildings are energy efficient and high performance, hence the name, Building Performance Architecture. And another aspect of QA/QC we do is around building envelopes in particular, which is the roof, the walls, the floor slab, and the basement walls and stuff like that. Making sure that the building envelope is airtight and watertight and heat tight. It doesn't have too much heat loss or heat gain through the envelope. So with that, I wanted to just get into explaining a little bit about what I mean by QA/QC drama. And basically, in our work, we see a lot of things, and in making sure that the buildings that contractors are building are as good as they're designed to be, and meet their performance targets and actually get the certifications that have a bunch of requirements. It's not easy to do those things, and the efforts to get there are actually pretty dramatic, and dramatic things can happen. We don't ever want to see goals missed, but we're actually there to catch those type of things if they happen. And we're also there to verify that the buildings are really doing great, and we love to see that. This episode I'm going to talk a little bit about roof issues, which is something that has happened lately. But first, I just wanted to do a little bit of news for BPA, and it also kind of explains the range of project types that we do. So in the past week, I had someone call and tell me that they had 3 projects that they'd like me to look at. The first project was a single-family home. It's going to be a high-performance home, and they wanted me to do the QA/QC verification and testing and make sure that the house is meeting the performance targets that they're establishing for it. The second project is kind of a mid-sized building renovation project. It's a commercial building that is being renovated by a school and turned into a school facility. And that also has some pretty high performance targets associated with it. And then the last project that he told me about is a 2-building apartment complex. And each of the buildings is 12 stories tall, and in total there are about 460 apartments in those buildings. And so, we're going to be doing proposals for all 3 projects, and we've done things on those scales, even up to testing very large apartment buildings for envelope air leakage and doing infrared scans and stuff like that. So just the range of things that we do. And now on to the roof QA/QC drama. Okay, so roofs are very important parts of the building envelope, in that they are the main location that keeps water out of the building and makes the building watertight. And in addition to that, the roof also has to be airtight, and it still has to also be a good thermal barrier. So the combination of those 3 things makes roofs very important. And the building we're going to talk about has what's called a flat roof, not necessarily completely flat. It's sloped enough to have water gently roll towards roof drains that are in the middle of the roof. And then those drains will take the water down below the building and out. So there are a few things in this roof that we found, and I guess I'll go ahead and explain the principles behind them. So this photo actually is a good representation of most of the issues that we had. So one of the things that roofers are supposed to do when they get done with part of a roof for a day, they're generally not able to finish a whole large building's worth of roof in one day. So they will do a section and then they have to stop at the end of the day. And what they do when they do that is they lay the roof membrane over the top of the insulation boards that you see here, and they just lay it over and let it lap over onto the bottom of the roof system. And you see that they did that on the left side of this picture, but they did not do that on the front of the picture. And so they left it like that, and it was a Friday, and they went home for the weekend, and it rained all weekend. And we got back on Monday, and we saw this, and the rain was able to get into the insulation layer, and it's able to get on top of the insulation, and it's able to get underneath the insulation, which is the opposite of what you want when you're installing a roof. You want everything to be dry, because you don't want moisture to get trapped inside the roof system. So just to give a short explanation of the roof system in general, what you see on the bottom, the lighter gray, is what's called the vapor barrier, and that's adhered right onto the roof deck, which is made out of wood. It's like a wood board material. So that stops water vapor from getting through the roof in either direction, either from inside to outside or outside to inside. It stops water vapor. It also stops air. So that's the air and water vapor barrier. Then you'll see the thick white layers there. Those are roof insulation boards, and there's 2 layers of them. We'll go into why that is in a little bit. There's a very thin layer of white material on top of the top insulation board that you can see toward the right. That's actually a protection board. It's made out of gypsum, kind of like drywall that they put on walls. And that's just a hard board material that makes it so that someone can walk on the roof if they have to, and they won't crush the insulation layer when they walk across the roof. And last, on top of everything, is that black roof membrane itself, which is the waterproof layer. So water cannot get through that, and it will shed water down a gentle slope to the roof drains. So the next issue that we'll see here in this picture is those 2 layers of insulation. And the reason that there are 2 layers is because it's actually kind of like bricks. You want to have the layers offset so that the joints are not lined up with each other, and so that if any shifting happens in those roof insulation boards, you don't have joints opening up where heat can get up through the insulation joints and out of the building. When that happens, that can cause not only heat loss, but things like condensation of any moisture that might be in that roofing layer. And you really don't want that to happen. So you have 2 layers of insulation. You have the joints offset so that at one joint, there's actually a board on top of it covering that joint, and then the joint for the top board is somewhere else. So, heat has a lot harder time getting through, and you don't get an open joint all the way through the roof insulation if anything shifts. So they did that staggering here on this roof. On the left there, you see that the bottom board is going farther to the left than the top board, but they didn't do that on the front of the insulation board layers. So on the front, you see they have the two boards aligned with each other, and if they had kept on going with this, they would have had an insulation joint that went all the way through the insulation layer. So we wouldn't want that to happen. We'll go to the next picture that'll show the extent of that. So you can see that these two layers of roof insulation board, where the edges are directly above each other, which is not what you want. That actually goes for probably 100 feet along the roof surface there. And then you can also see there's quite a bit of water still on the roof from the rain that lasted all weekend. And actually you can sort of see a little bit of bending and bowing of the roof insulation at the joints. That might be normal, but the fact that those edges were open to the water all weekend long is not. So we'll go on to the last photo and the last dramatic roof issue. All right, so the last QA/QC piece of drama here that we're going to go over with this roof is the insulation thickness. The drawings for this project called for 2 layers of roof insulation, and each of those 2 layers was supposed to be 2.6 inches thick for a total R value of R30. So one of the things that we do is we actually check on things like that that get installed. And in this case, took a tape measure and measured those 2 layers of insulation. If they were each layer was 2.6 inches, the total thickness would have been about 5.2 inches. And you can see here that the total thickness in reality is less than 5 inches. In fact, it looks like it's about 4.8, which would put those insulation boards at about 2.4 inches thick instead of 2.6. So not that it made a huge difference in energy performance. We actually had somebody look at the impact on energy using an energy model. Didn't make a lot of difference, but we just, in general want to make sure that the owner is getting what the drawings called for, because the contractor is supposed to provide what's on the drawings within the contract price. So we called this to the contractor's attention, and we actually got kind of an interesting response, which was that, in fact, the packages of insulation that had been lifted up to the roof with a crane had labels on them, and the labels said that these insulation boards are 2.6 inches thick, which doesn't really match with what the tape measure showed. And excuse my computer, it's going through some issues, but anyway, and then they also said that the roof manufacturer said that there's specific ways that you're supposed to measure the insulation to make sure that you're measuring it properly and you're getting the thickness accurately. supposed to measure it at multiple points, not supposed to measure it at corners because corners could be crushed in some way or be compressed. And I actually don't see any compression in this photo that I took. It looks like the corner is pretty much the same thickness as the whole rest of the board. So anyway, I would be surprised to see, if we went back and went through the exact measurement procedure that the manufacturer prescribes. I'd be surprised to see that we got any different results there at all. So it just gave everybody pause, and we had to stop and check and see, okay, what's going on here? Why doesn't it look like it's as thick as it's supposed to be? Is it a problem? And we don't actually want to see things like this. We want to see everything in a new construction project, be exactly like it's supposed to be the first time. But that's not always, it doesn't always happen that way, and that's actually why, one of the reasons why we are hired on these jobs, to make sure that the owner is going to get the building that was designed. So that wraps it up for this QA/QC drama on roof systems. And thanks for watching, and we'll come back next time with some more QA/QC drama, probably on a different topic. So until next time, thanks for watching. Bye.